Namaste everyone. Welcome you all to Sadvidya Academy Physics classes by Ganesh Shabar. Today's topic is Class 11 Physics, Chapter number 1, Units and Measurements, Part 5, Significant Figures. In this particular concept, we shall discuss about the significant figures. So what are significant figures? The definition of significant figure is it is or significant figures are the numbers from LSD to MSD. What is the meaning of LSD? Least significant digit. Significant digit. And what is MSD? Most significant digit. Most significant digit. So that is MSD and LSD. So significant figures are the number of digits from LSD to MSD. Least significant figure in the most significant ವರೆಗೆ ಎಷ್ಟು number of digits ಇದೆಯಾ that we call it as the significant figures. If I consider, say for example, a number 1.2123 like this, if I say, then ಯಾವುದು ಕಡಿಮೆ significance ಇರುವಂತದ್ದು last number 3, and which is the most significant one is 1. So number of digits from here to here 1 2 3 4 5. So significant figures is equal to 5 ಅಂತ ಕರಿತೀವಿ. But if the main challenge is with the finding MST and LST. So there are different rules for finding the significance of any digit, whether it is significant or not. So adana find out ಮಾಡ್ಲಿಕ್ಕೆ there are some rules. So which are they? We shall see that one by one. First rule is all the non-zero digits are significant. Just now I have given this number, that is 1.2123. Here any digit is other than say for example, if any digit is 0 here, no digit is 0. All the non-zero digits other than 0, whatever the digits will be there, all are significant. That you have to consider into account while finding the number of significant figures anta. And second point is all the zeros between two non-zero digits are significant, no matter where the decimal point is, if at all. That means, what is the meaning of this? Say for example 1.210023, if I write this particular value. So these zeros are situated in between two non-zero numbers, right? All the zeros between two non-zero digits. So there is a non-zero digit here and there is one more non-zero digit here, this one. So these two zeros are in between this one and this is 1. So in between this 1 and 2. So these zeros are significant. If any zeros are situated in between the two non-zero digits, then they will be significant. You have to count them also while finding the number of significant figures. That is the meaning. So what is the number of significant here in the given number? It is 1. This is the most significant. This is the least significant. 1 2 3 4 5 6 7. So 7 is the significant figure. And next, if the number is less than 1, there is a condition. If the number is less than 1, the 0 on the right of the decimal point but to the left of the first non-zero digits are not significant. It is very important. Let us consider if the number is less than 1. So there is a condition if the number is less than 1. So let us take a number less than 1, 0.002456. This is a number. Now the zeros on the right of the decimal point, this is the decimal point here, and the zeros towards the right of the decimal point, that means this 0. And but to the left of the first non-zero digit, this is the first non-zero digit, towards the left of that. So these two zeros, according to this rule, it says that these two zeros are not significant. No need to take them into account while finding the significance of a digit. So which one becomes the least significant figure? This 2 becomes the LSD and 5 becomes the MSD. So number of significant figures is 1, that is 2 to 6. So 1, 2, 3, 4. So which is equal to number of significant figures is equal to 4 in the given question, the given problem. Then the terminal or trailing zeros in the number without a decimal point are not significant. What are trailing zeros? Terminal or trailing zeros in the number without a decimal point. Let us assume there should not be any decimal point. 1, 2, 4, 5, 0, 0, 0, 0. This is a big number. So these zeros, trailing zero, this is a number without a decimal point, right? So in these numbers, such numbers, all these zeros, these are called as trailing zeros or the ending or terminal zeros anta ಕರಿತೀವಿ. So all these are not significant ಅಂತ ಹೇಳುತ್ತೆ ಈ rule. These are not significant. So what is the number of significant figures? So which is the most significant figure? This is the most significant figure, that is MSD. This is the least significant figure. Then these zeros are not significant. Then number of significant figures in this number is 1, 2, 4, 5. So 1, 2, 4, 5. These are for the 4 significant figures. So the number of significant figures is equal to 4. Next is about the next one more rule. Trailing zeros with in a number with a decimal point are significant. Listen this. If there is a number with a decimal point 1.2345610000. Now if it is the case here, these zeros, these are all trailing zeros, is it not? But it is a number with a decimal point. So in such a case, these are significant ಅಂತ ಹೇಳುತ್ತೆ. This is the least significant digit and this one becomes the most significant figure. Now total number of significant figures is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 is the total number of significant figures. I hope you have understood this. That means trailing zeros in a number with a decimal point are significant. You have to take into account of them. So next rule is, what is the next rule of finding the significance? For a number greater than 1 without any decimal point, the trailing zeros are not significant. For a number greater than 1 but without any decimal point, the trailing zeros are not significant. If the number is greater than 1 but it has no decimal point, so say for example 831400000. Now these are all the trailing zeros but without a decimal point. This should not have any decimal point. It has no decimal point. So all these numbers are not significant. So number of significant figures is only 8314. 8 is the most significant and 4 is the least significant. So number of significant figures is 4 in this case. And next one, for a number with a decimal, the trailing zeros are significant. For a number with the decimal, if there is a number with the decimal point, let us assume there is a number with the decimal point, the trailing zeros are significant. What does it say? It says 7.43200 if I write. So these are the trailing zeros here actually, but this has a decimal point here. So since it is a number with the decimal point, all the trailing zeros are also significant. So which one becomes the most significant? 7 becomes MSD and this last 0 becomes the LSD. Number of digits between MSD and LSD is called as significant figure. So 7, 1, 2. So 1, 2, 3, 4, 5, 6. So 6 is the number of significant figures in this particular concept, in this particular given example. Here we shall discuss some of the rules for the mathematical operations with significant figures. So how to do the mathematical operations if there are some numbers which are, say for example, least significant or most significant, etc. In such case, how to know in that particular calculation how many digits to take it as significant, and how many not to take it as significant, how to know that. So that is studied using these two rules. In multiplication or division, the final result should retain as many significant figures as there are in a original number with the least significant figure. What does it imply? What is the meaning of this? Let us assume a number. Say for example, there is a number 1.21 into, I will multiply this number 1.21 into 2. It is not 21, it is 2.41826. I will multiply this with some number. Say there is a number 1.21, that is 1.21 into 2.41826. If it is the case, then what is the answer for this? Answer is you will get the answer as 2.9260946. How many number of significant figures to retain in this particular given question is a problem. So in such a case, there is a ambiguity in choosing number of significant figures. So the rule says that according to this, in multiplication or as well as division, same is the case with division, the final result, whatever the final result I got, 2.9260946, that much. Final result should retain as many significant figures as there are in the original number with least significant figure. Which are the original numbers? These two, this one and this one. Here how many significant figures are there? 3. Here how many significant figures? 1, 2, 3, 4, 5, 6. So which is a number with the least significant figure? It is only 3. This one, first one, 1.21. So here also, in the answer also, I can retain only 3 significant figures only. I can skip the remaining ones. 60946 I can skip. But there are also, in skipping that, there are also some of the rules which we study later. So, but this says that, this particular rule says that in multiplication or division, what should be done? ಎರಡು ನಂಬರ್ ಇದ್ರೆ ಆ ಎರಡು ನಂಬರ್ಗಳಲ್ಲಿ ಯಾವ ನಂಬರ್ ಅಲ್ಲಿ ಕಡಿಮೆ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ಸ್ ಇದಾವ ಅಷ್ಟೇ ನಂಬರ್ ಆಫ್ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಫಿಗರ್ಸ್ ಅನ್ನ ಫೈನಲ್ ಆನ್ಸರ್ ಅಲ್ಲಿ ರಿಟೈನ್ ಮಾಡ್ಕೊಳ್ಬೇಕು ಅಂತ. ಉಲ್ಡ ನಂಬರ್ಸ್ ಅನ್ನ, ಉಲ್ಡ ಡಿಜಿಟ್ಸ್ ಅನ್ನ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಬಹುದು ಅಂತ ಹೇಳುತ್ತೆ ಈ ರೂಲ್. ನೆಕ್ಸ್ಟ್, ವಾಟ್ ಅಬೌಟ್ ದ ಸೆಕೆಂಡ್ ರೂಲ್? ಸೆಕೆಂಡ್ ರೂಲ್ ಆಲ್ಸೋ ಇನ್ ಎಡಿಷನ್ ಆರ್ ಸಬ್ಟ್ರಾಕ್ಷನ್. ಫಸ್ಟ್ ಕೇಸ್ ಈಸ್ ವಿತ್ ದಿ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಅಂಡ್ ಡಿವಿಷನ್. ಸೆಕೆಂಡ್ ಒನ್ ಈಸ್ ಇನ್ ದ addition and subtraction. The final result must retain as many decimal places as there are in the number with the least decimal places. Same thing, 1 point, if I take, say for example, if I take the value as 1.48 plus 2.31406. If I take this value, there is plus I have done addition. If I add this 1.48 plus 2.31406, whatever the answer I get is, so answer is, actual answer from the calculator is 3.79406. This is the answer actually. But according to the rule, how many digits I have to keep? In addition or subtraction, the final result must retain how many number of significant figures? As many the number with the least decimal places. Which is the least decimal place? It is having the least decimal place. So you have to retain only 3 here. That is the rule. It says 3.79. It is enough if you write 3.79. You can skip the remaining 406. That is the statement. That is the meaning of this particular concept. In the previous slide, we have discussed we can drop some of the non-significant digits. But While dropping also, there are some methods to drop. So that is called as rounding off the uncertain digits. What are rules? If the insignificant digit to be dropped is more than 5, say let us assume, there is one example I will give you. So it is 1.240894. This is the example I have given. They may ask you this question that you adjust that number to 1, 2, 3, 4, 5 decimal places. 5 decimal places, or round off the given number to 5 significant places ಅಂತ ಕೇಳ್ತಾರೆ. At that time, how much values you have to retain? You can retain only up to this 8. But whether you are simply dropping the remaining 194, there is a rule. So if the insignificant digit, which is insignificant now, you have to round it off to 1, 2, 3, 4, 5. 5 significant places only. So these are insignificant now. These are insignificant. Now which is the number? This is 9. So whether it is less than or more than 5, so it is more than 5. In such a case, what should be done? Then the preceding digit has to be raised by 1. That means this 8 has to be done as 8 plus 1, or I can write 1.2409 ಅಂತ ಬರಿಬೇಕು. 1.2409 ಅಂತ ಬರಿಬೇಕು. That is the method of rounding off. I have rounded it off and I have removed the remaining one. 8 I have done it as 9. Why? Because the next number, that is 9, is more than 5. If it is more than 5, then the preceding number to be raised by 1. Now suppose if the insignificant digit is to be dropped is less than 5, then the preceding digit is unchanged. Is the say let us assume say for example it is 12.14256. They may ask you this. So round off the number to how many decimal places? You have to see, that is 1, 2, 3, 4, 5 decimal places ಅಂತ ಕೇಳ್ತಾರೆ. Round off the following number to up to 5 decimal places ಅಂತ ಕೇಳ್ತಾರೆ. At that time what you have to do? The sixth one is uncertain, or sixth one is not significant, right? So which one is the sixth decimal? 1, 2, 3, 4, 5, 6. This is 5. This has to be dropped. So 1, 2, 3, 4, 5. 2 is the fifth digit. You have to drop 5 and 6. At that time, now if the insignificant digit which is to be dropped, it is 5, is less than 5. If it is, say let us, I will take this number as 4. Sorry. So while giving the example, it was a mistake. Yeah, I will give the example as 12.1424 ಅಂತ ಕೊಡ್ತೀನಿ. That 4 value is less than 5, right? At that time what we need to do? You can simply neglect that number and you can retain the same value, 12.142. That's it. No need of changing. You can simply drop the uncertain digits. That's it. And if it is equal to, say for example, if it is equal to 0, if the insignificant digit dropped is 5, then what should be done? Then there are two cases here. In this case, there are two cases. Say I will erase this for the timing. Yeah, I will give the example. It is 124.852. If it is the case, then what should be done? I will give you two examples. There is one more, 484.26. It is 26. I will write it as 275. It is the case. Here you need to round it off to this particular digit. This particular, only you have to retain 2 decimals after the 2 digits after the decimal point. Here also you have to retain only 2, say for example 1 digit after the decimal point. At that time what you have to say? These are insignificant. You have to adjust it to only 4 significant figures. Here also you have to adjust it to let us assume that you have to adjust it to 5 significant figures here. Now Alva. So now you have to look into the number which is insignificant. Which one is insignificant? Here it is 5 and 2 are insignificant. So which is insignificant digit? That is 5. Now at that time if it is equal to 5, less than 5 ಆದ್ರೆ ಏನು ಮಾಡಬೇಕು, greater than 5 ಆದ್ರೆ ಏನು ಮಾಡಬೇಕು ಅಂತ ಡಿಸ್ಕಸ್ ಮಾಡಿ ಆಯ್ತು. ಈಗ if it is equal to 5, then you have to look into the previous number. So then you have to look into the previous number, and what you have to do is look into the previous number. If the preceding digit is even, then the insignificant digit is simply dropped. Look into the previous number. That is, sorry for this. I will write it somewhere here. Shall I write it somewhere here? Okay. So if it is even, say 124.452. This is the number. You have to adjust it to 4 decimal places. So which are the insignificant? This 5 and 2 are insignificant. Is it not? So at that time what you have to do? So this 5 is equal to, yeah, it is 5. Not less than 5 or more than 5. At that time you have to look into the previous number. Previous number is 4. It is even or odd? It is even. If it is even, if the preceding digit is even, then the insignificant digit is simply dropped. So insignificant digit is no change in the previous digit. You have to simply drop it and you have to write it as 124.4. That's it. So you can simply drop the insignificant digit. Now next number, if the preceding digit is odd, I will give you one more example. 124. Say for example 752. This is the number. Now you have to adjust it to this many decimal places only. So this number to be dropped is 5 and 2. At this 5, just before the number 5 is 7. Whether it is 7 is even or odd, it is odd. So at that time, if the preceding digit is odd, the preceding digit is raised by 1. At that time you have to write it as 124. In place of 7, it should be equal to 8. This is how to rounding of the digit. These are the rules of rounding of the insignificant digit. Thank you so much.